Hello, welcome to our specific heat capacity required practical for the physics at GCSE. So I thought I'd first of all try and show you what specific heat capacity is, because it's quite a difficult concept to understand. So let's have a look at it in this real life example. Take a hot tub for example. We have to raise this water from coming out of the tap. It's pretty cold, so raising it every degree is taking a significant amount of energy. And every time we raise 1 kilogram, a given mass of this, per degree, it takes some energy. So we can calculate the amount of energy required to move a material at 1 degree for any given mass by doing an experiment. Let's have a look. So as you can see, I've got my power pack running at 12 volts. And keep it at 12 volts, that's what my heater is running at. Then in series, I'm coming down to my ammeter from my negative part of the power pack and through to my heater. The heater is inserted in the aluminium block, and I'm using a thermometer to take the temperature. My series continues back to power pack, and then I run my voltmeter in parallel. So for your reference, here's a diagram of how I've wired up my circuit. So here you can see I'm taking a starting temperature, 20 degrees Celsius, and that's about room temperature. I'm going to turn on my ammeter and turn on my voltmeter now, and just pop my aluminium block on a heat mat and turn my power pack on. And then I take a reading of the voltmeter, 12.09 volts, and reading of my ammeter, 3.61 amps. So I immediately start the stopwatch. I'm using a timer online for this. So to calculate our specific heat capacity of aluminium, we are going to have to work out our power. And so what we do is we get our current and we times it by our potential difference. So our power is measured in watts, our current is measured in amps, and our potential difference is measured in volts. So using the figures we recorded on the voltmeter, 12.07 volts, and the measurements we took on the ammeter of 3.63 amps, we can now calculate what our power will be. (43.81 watts). So the next thing we need to work out will be our energy, the energy used over the time that we've taken. So we are going to use the power, the watt measurement, and the time that we took. Power being in watts, time being in seconds. And our energy measurement is going to be in joules. So the heat has been running now for 6 minutes. And we're going to take a temperature measure from our thermometer. And it's looking at the moment like it's reading 32 degrees Celsius. So we can find that temperature difference now by taking the start temperature and the end temperature and using the end temperature to take away from the start temperature, therefore giving us a temperature difference of 12 degrees Celsius. Something we mustn't forget as well is that we cannot use the minutes. We have to use it in seconds. So we're going to get the 6 minutes and times them by the 60 seconds to give us 360 seconds. So using the 360 seconds and the 43.81 watts in our power times time equation, we can now work out how much energy has been transferred over that time. So we're going to times the two together, and it's going to give us 15,771.6 joules. Now I've rewritten this next part so you can see it a bit more clearly. We have our energy transferred, our temperature change, and we also have the mass of our material, which is a kilogram of aluminium. Now the specific heat capacity equation is our energy transferred is equal to our mass times our specific heat capacity times our temperature change. And sometimes that can be represented in symbols and letters as follows. Here we can see the equation with a little bit more clarity and how the symbols will look often when we see them on our spec sheets. And what we've got here now is I've rearranged that equation so that the energy is divided by the mass times the temperature change, and that will give us our specific heat capacity. So I'm now going to write that down so you can see what we can do with the figures we already have. So using the 15,771.6 joules, we can get the mass, which is the 1 kilograms, and times that by the temperature change to give us 12. And we're going to divide 15,771.6 by 12. So, top tip, have a calculator with you when you're in your exam or in your lesson so you can easily work out and calculate these equations. So we can now see we have our grand total of 1,314.2 joules per kilogram for every degrees Celsius that aluminium has to be raised by.
Good. I hope that helped with your studies, and good luck in your exams, Year 11. And don't forget, subscribe.